All right, section 4.4, we're still talking about triangles, and we're still talking about congruent triangles. But let's review just briefly. We went over a whole homework assignment where we talked about this, but let me just go over it just real quick because it kind of leads into what I'm going to talk about today. Now, right now, if I put those two triangles right now, can you say that they're congruent to each other? No. You can't, because you don't know anything about them, do you? You don't know the lengths of the sides, you don't know the angles. You don't know anything about them. But let's label them so we can refer to each of these sides and angles. D, E, F. This is kind of like review. So what if I told you that this angle was equal to this one was equal to this one, and this angle was equal to this one right here? Is that enough right there to say the triangles are congruent?
Yeah. No,
the sides have to be equal as well. Good. Okay, so let's say that this side is equal to this side. And let's say that this one is equal to this one, and this one right here is equal to this one. Now look, I've shown all 6 parts, haven't I? There's 6 parts to a triangle. There's 3 what? 3 sides and 3 angles. That's right, that's 6. There's 6 parts of it. So if all 6 of these are equal to all 6 of these over here, then what can I say about these 2 triangles? What's my congruent statement here? Triangle what? ABC would be congruent to what? Triangle DEF. Now up to this point I needed to know all 6 things. I needed to know all 3 angles and all 3 sides in order to say that these 2 triangles are congruent to each other. But today we're going to learn 2 ways that we don't have to show all 6 of them. Okay, we don't have to say that all 6 of these are all equal to all 6 of these. We actually kind of split that number in half, where we only have to show 3 things from here equaling 3 things from here. You don't have to show all 6. Up to this point, the stuff we talked about yesterday, you had to show all 3 angles and all 3 sides. But today you're not going to have to because of this thing called a postulate. We've used that word before, haven't we? A postulate. What's the difference between a postulate and a theorem? A theorem, you can do what to it? You can prove it. Good. That's right. Good. See, Justin was listening. On a theorem, you can prove it. You can prove a theorem. But on a postulate, you just accept it without proof. Okay? You don't have to prove it. You just accept it. And that's what we're going to do here. Let's just go ABC again. Not being very creative with my lettering, but that's okay. Makes it kind of easy. All right, so there's my 2 triangles. I don't know anything about these triangles. I don't know if they're congruent, not congruent. I don't know anything about it. But let's say the book, or you're able to figure this out, or they number it, or something like that. The book tells you this. Let's say they tell you that this side is equal to this side. Is that enough right there to say that these triangles are congruent? No, just because this one side, I mean, look, this side could be like way down here, couldn't it? And this side could be real short, and they wouldn't be the same, would they? Even though these 2 sides would still be equal to each other. That's not enough. What about showing that these 2 sides are equal to each other? Is that enough to show that these 2 are equal to these 2? Is there any way to make this triangle look different than this, keeping these 2 sides equal to these 2 sides? You hear what I just said? Look, if these 2 sides are equal to these 2 sides, does this 3rd side have to be equal? No, it doesn't. I'll show you why. Watch this. Let me ungroup it here. And let's grab this. I'm going to make it so I can rotate it. Watch this. Now, I'm not changing the length of this side at all. All I'm doing is just turning it up a little bit like this. Okay? And we'll put that right there. That side's still equal to that side. Would you agree? And this side right here, the 2nd side, is equal to this 2nd side. But does that mean our triangles are still congruent to each other? Look, there's my 3rd side right there. Are these triangles congruent to each other now? No, absolutely not. They look completely different, don't they? All right? So just because I got 2 sides equal to 2 sides, does that make these 2 triangles congruent? No, it doesn't. Okay? But if I did this, if I told you, or the book told you, that this side right here was equal to this side right here, is there any way I could take this triangle over here and make it a different triangle? All right? A triangle that's not congruent to that. Is there anything that I can do? What if I took this and I twisted it around? Well, if I made it smaller, then this side wouldn't equal this side, would it? Okay? can I change the angles of it or anything? No, because if I change it, I would be changing the lengths of the sides as well, wouldn't I? All right, so there's no way, there's nothing that I could do to this. Some people might say, well, you could like flip it around like that. Now they're not congruent. Did I really make them not congruent there? No, they're still congruent, right? I didn't change the lengths of the sides. I didn't change the angles. All I did was just twist it around, right? It's still congruent to this. So look, right there. I don't have to show that all three angles are equal to each other. All I got to do is show that three sides of this triangle are congruent to three sides of this triangle. That's all I have to do. All right, and let me show you something. We call this a postulate. Let me go up. All right, we call it a postulate, and we call it the side. Write this down. Side postulate. Look, I'm constantly writing. If you're constantly writing, your head won't be on the desk, all right? Because it's difficult to write when your head is on the desk. So keep your head up and write this down. Write it down. Borrow one. Get one from somebody. You got to come prepared. So side is the reason for this. And what does this tell you? It tells you that one side, look, see this one side is equal to this one side? The second side is equal to the second side, and the third side is equal to the third side. So we call it side. Instead of writing it out like that, we can shorthand it. What's a nice, easy way do you think we can shorthand it? Yeah, just write SSS, okay? But we don't say SSS. If I ask you, why are those triangles congruent to each other? You don't say it's because of SSS. What do you say? It's because of side. I put that in quotation because that's what we say, okay? We say it's side. Understood? Don't say SSS. We write it SSS just so we don't have to write so much. But we say side. What's that? No? Okay. So this is called the side postulate. And if you told me, well, prove that it works. I can't really prove that it works. There's really no proof for it. Okay? It's because it's a postulate. Okay? Side postulate. Or you can just write SSS. You don't even have to have that word postulate. I don't even care if you put that word postulate next to it. If you just write SSS, it stands for side. So if I give you a situation and I said, tell me why, and I'm going to ask you that quite a bit. Give me a reason. Give me a reason why this triangle is congruent to this triangle right here. What would your reason be? Side. Right? That's what I said right here, isn't it? That's a reason why these two triangles are congruent to each other. So if I know I got three sides of this are equal to three sides of my other triangle, then my triangles are going to be congruent. So when we do these problems, I'm going to ask you why. And the reason is these triangles are congruent because of side. All right? And that's what I'm concerned about. I'm concerned about the reason why. That's why I'm going through this. Let's talk about something we talked about yesterday in one of those videos. Do you remember that CPCTC thing? All right, let's talk about that for a second. I didn't say anything about these angles yet, have I? But watch. I've determined that these triangles are congruent to each other. So if these triangles are congruent, that means I could take this triangle, sit it right on top of this triangle. It's going to be exactly the same. What else must be equal then? The angles must be equal, right? Because we've already established that they're congruent triangles. So if they're already congruent triangles, what can I say about angle A? It's the same as angle D. Now, how did I know it was the same as angle D? Just because it's up top? Okay, what I do is this. I look to see what side it's opposite. Because remember, I could take this thing and rotate it around, couldn't I? And so how would you know what angle was equal to what? Well, look at this. Well, sometimes you can't just look, because look, that angle right there kind of looks like the same as this, doesn't it? So I'm not really sure if A equals D or B equals D. They kind of look the same. I can't go by the looks. So what do I go by? Look at angle A. We talked about this yesterday. Angle A is opposite the side with 3 tick marks. You see it? What angle is opposite the side with 3 tick marks over here? D is, right? See, there's the 3 tick marks. See, I flipped it, or I just twisted it around just to make it look a little different. So this has 3 tick marks. This is the angle opposite this side. So it's got to be equal. What about this one? What about angle B? Which one over here is equal to angle B? Well, they both kind of look like they could be. But how do I know? I look to see the side opposite, across from it, right? So look across from it. That's got 2 marks, right? So here's 2 marks. So which one? It's E. Good. So it's right there. Does that make sense? Now, if you get 2 angles equal to 2 angles, you know the third are going to be equal, but let's just make sure it makes sense. Let's take a look at C. C is opposite the side with 1 arc, or 1 mark, right? 1 tick mark. Look over here. What angle is opposite the side with 1 tick mark over here? It's F, isn't it? So that has to be equal. Everybody see that? Now, why is that all true? Now we got a couple reasons here. The reason that the triangles are congruent is because of side, side, side. But why is angle A equal to angle D? Not because of side, side, side. Why is angle B equal to angle E? It's not because of side, side, side. Why is C equal to F? Again, it's not that. What's that thing we saw yesterday on that video? Remember the letters? We said it earlier. Just give me a couple of the letters, at least. Starts with a C, right? Remember that? C, P, C, T, C. Let's figure out what that stands for. It stands for this. Write it down. This should be part of your notes. Corresponding. Now, it's CP. What did the P stand for? Parts. Corresponding parts of, now we don't use the O in our little letter thing, okay? Of congruent triangles, good. Congruent, yep. Triangles, I'll write the word. Triangles are congruent. Everybody should be writing this down. Now, what does this mean? This means this. If I've established that the triangles are congruent, did I already say the triangles are congruent? Yeah. Why are the triangles congruent? Side, side, side. Just side, side, side is all you got to say. Okay? Side, side, side. All right? So now we know the triangles are congruent. What about all the missing parts? What about all those corresponding parts? What must be true about them? They got to be congruent too. Why are they congruent? Why is angle A equal to angle D? Okay? Question mark. Why? Why is angle B equal to angle what? E, right? And why is angle C equal to angle F? Why is that true? Question mark. Well, it's because of this. It's because the corresponding parts of congruent triangles are congruent. Think of what this means. A and D, they're corresponding angles, aren't they? And they're congruent triangles, aren't they? Does that fulfill this thing right here? Are they corresponding parts of congruent triangles, A and D? Yeah, they are. So what must be true about them? They must be what? They must be congruent. They must be equal to each other. I taught out of another book where I said equal instead of congruent right here, but this book says congruent, so we'll use that. Okay? Why is angle B equal to angle E? Well, look, they're corresponding parts. They match up with each other, and they're part of congruent triangles, right? They're corresponding parts of congruent triangles, so what must be true about them? They've got to be what? Congruent. See how that works? And then C. C and F. They match up with each other. They're corresponding angles. Okay, so if they're corresponding angles of congruent triangles, they have to be equal as well. All right, so here's what we do. Remember the letter? You guys said it earlier. I'm going to circle the letters that we use here. We don't use the O from of and the A for R, but we just use the main words right here. We call it what? C, P, C, T, C. That's really important. Okay, we're going to use that. When do we use it? We use it when we're trying to show that missing parts are congruent to each other. All right? We don't use it to prove the triangle's congruent. We use it just to say that angle A is equal to angle D, angle B is equal to E, angle C is equal to F. So here's a big question mark, right? Why is all that true? Why are these things equal to each other? Somebody tell me real quick. We just did it. That's right. That's your reason. CPCTC. Okay? It's a little confusing at first. I completely understand, okay? I was there too. I remember when I took geometry and I was like, what in the world are they talking about? But after a while, you start getting used to it and you start understanding what this stuff means, all right? So you might not get it completely right off the bat, but after we do some things and after we go through a couple more lessons, then it'll make a little bit more sense to you. I mean, this doesn't look anything like math, does it? I don't even see any numbers in here, do I? Are there any numbers at all in this? Nope, not one number in this whole thing. And it's math. Can you believe it? All right, but it's geometry. It's a little different. We're trying to prove triangles congruent. All right, we learned one way. One postulate was side, side, side. I have another postulate I'm going to show you. And we're going to do just 2 postulates today. We'll do a couple more tomorrow. There'll actually be theorems tomorrow. But today is another postulate. We'll keep the same triangle. Might as well keep it looking the same. This works with any triangles. It doesn't have to look like this. It doesn't have to be an acute triangle. And, all right, I'm really getting tired of ABC. So give me some letters. P, Q, R. How about that? And then X, Y, Z. How's that? Be a little bit different. Now watch this. This time I'm not giving you all the sides are equal to each other. I'm giving you something else. I start off giving you a couple sides. All right, so I start off telling you that PQ equals XY. All right, how do I know that? Just because they tell us. Okay, they tell us that they're equal to each other. I'm also going to tell you that PR is equal to XZ. But I'm not going to tell you that QR is equal to YZ. Okay, I don't know that. I haven't measured it. I'm not really sure. But I am going to tell you something else. I'm going to tell you, look at the angle that's in between these 2 equal sides. That would be this angle right here. Do you see that one? And what about this angle between these 2 equal sides? Or not 2 equal sides. I shouldn't have said that. Between these 2 sides, okay? That's that angle. And between here, that's the other angle. Now, we don't usually say between when we're talking about this. We say this is called the included angle. All right? That's an angle symbol. We call it the included angle. The included angle is the one that's between the 2 sides that are given. All right? Everybody writing this down? Is that us already? Oh, my word. Well, anyway, watch what we call this. What do you think we call this thing? I got a side, I got an angle, and I have a side, so I'm going to call it what? Side, angle, side. Wow, time went pretty quick. That's right. I'm going to give you a worksheet tomorrow to work on, and we got a couple more things I want to talk about. So no homework tonight. I'll give you a worksheet tomorrow.